Here composite joins, joining on multiple columns. What is composite join? How to join on multiple columns, right? We will cover complete composite joins. A composite joins is where we need to join like tables that are related based on multiple columns. Okay, let's get started. Here one table is cities, one is stores. That's an example. We have a table of cities and we have a table of cities, we have a table of stores in the cities table, right? We have the population of each city, the name of each city and the country. Population, city, country, right? City, country, store ID, area. Like, note that we have two cities, right? We have Melbourne in the USA and Melbourne in Australia. Therefore, we cannot use a city attribute by itself to uniquely identify each row, right? So here instead we need to use both the city and country columns to uniquely identify each row in the cities table, right? Looking across at the stores table, each row is uniquely identified by the store ID column, and here we have the full size of each store and square meters in the area square meter column, right? And we have the city and country which each store is located in a store state. One is in Melbourne, USA stores 2 and 3 are in Melbourne. Here USA stores 2 and 3 are in Melbourne, right? Melbourne and Australia, and Sydney 4, Australia. In order to correctly join these two, we need to join on both the city and country columns, right? City and country column. However, before we go through this, I want to show you what happens if we join the tables based on only one column. Let's see how. See, select in this statement we are in joining the city stores on only a city attribute, right? Notice this, that is the some select clause. We have included the country column from both tables of the country, right? Column from the stores table being aliased to store country. Okay, let's go for each of the rows that will get matched, right? So Melbourne USA gets joined to Melbourne from store wide one. Now when USA gets joined to Melbourne for store ID 2, however notice that store ID 2 is actually what happened actually in Melbourne, Australia, or not Melbourne. USA therefore is incorrect to join these two rows, and we can see that the country and the store country for this match 4 have different values. Next we have Melbourne USA joined to store ID there, right? Store ID 3. This is also an incorrect match as the countries are different. See, Melbourne Australia gets joined to Melbourne to store ID 1. So again this is incorrect. We can store ID 1 is in the USA, then we have see, Melbourne Australia joined to Melbourne for store to them, Melbourne Australia joined to Melbourne. See, for store ID 3, and finally we have Sydney Australia joined to Sydney for store ID. For this join has given us an incorrect result, as the query result includes that should not have been joined, because see they refer to different countries. In case if we want to get the correct result, then we need to join on both the city and country columns. Let's look at the correct query syntax. So now in the here we are joining on both city and country, right? See, select C population, cities, select cities, country, country as store and so on. From city C inner join stores S on C dot city is equal to S dot city and C dot country is equal to S dot country. So in both columns we are joining, right? So we have on city equals to S city, C city is equal to S city on the first condition, and then we have the AND operator, right? And then in the second condition we have set our country equals to S country, C country is equal to S country. So both this condition and this condition need to be met in order to get joined, right? We need to do this is because in the city and the city attribute does not have unique values, right? City attribute does not have unique values, right? As see, as we have two cities with the same name, also in the stores table city is not unique either. This means that we get a many to many relationship occurring when we join on just the city alone. To correctly to do join, we need to always join, right? There are different types of keys. However, here I am defining a key as a column which has unique values or set of columns like unique combinations of values. A key is a column which has unique values or is set of columns which has unique combinations of values. Right. So the key in the cities table is combination of city and country, as these have unique combinations of values, right? In the store table, the only key we have in the store ID column. Notice that in the stores table, right? Even if we combine the city and country columns that are not unique, this is because we have two store IDs 2 and 3 in the same Australian city. Right. However, we can still use these attributes to join to the cities table because city and country combined do form a key in the cities table. As long as at least one of the tables involved in the join as a key, then we can use this key to join on to the other table. Summarize, I like to remember that saying the key to a good join is to join on a key. Key to a good join is to join on a key. Let's go further and so which rows get matched when we join on both city and country. Country Melbourne, USA gets joined to store 1 ID and we get Melbourne. Australia gets joined to Melbourne, Australia for store 2 and also for store ID there, right? Store ID 3, and then we get Sydney, Australia joined to Sydney, Australia for store ID. For full complete illustration, let's include the city column from the stores table. We can now see that we get the correct result because both the city and country values from each of the two tables match. Let's see joining more than two tables. Alright, we have only been joined two tables together in this lecture. We are going to see how they join more than two tables. They are also referred to as a multi-join queries, right? Okay, let's go straight into it here. doctors to patients, patients, right? Doctor, patients, patients. Three tables is there. There is no direct relationship between doctors table on the right. However, we have like we have what's called an associate table, which is this table in the middle called doctor patients, right? This association table can be used to link the doctor's table to the patient table, right? The doctor's patients association table gives all the unique combinations of doctor ID and patient ID. Therefore, the key in this table is these two attributes combined, and association table is also known as a linking table, and it is used to model many-to-many relationship in relational databases. In this case, we have a many-to-many relationship between doctors and patients, as one doctor can see many patients and one patient can see many different doctors, right? So goal is to join these three tables together in order to get the doctors and patients they see. We can do the like by writing the following query. Do that by writing the following query. See, first we are joining the doctor's table to the doctor patient table. Second one is doctor patient table. First one is doctor patient table. Second one is doctor patient table. Third one is patient table. So first we are joining the doctor's table to the doctor patient table. Select d.doc id, doctor last name, p.patient id, patient last name from doctor's d, inner join doctor patients dp, doctor patients on id is equal to id. Here again inner join patients p on dp dot patient id is equal to p dot patient id, patients dot patient id, right? In this way we can join. Is followed by another in a join where we are adjoining to the patient table when we have multiple tables. So let's look at first join. See here we are joining doctors with patients on the doctor side, and this gives the following conceptual result. See this one, this virtual result is then joined to the patients table. This virtual result will join to the patient table. So we are in joining on the patients and we are joining on the associated tables. Patient ID, which is deep patient ID to the patients table, and patient ID, patient table, patient ID. See, this gives the following result. So now we have each doctor's ID and last name as well as each of the patients that they see, right? And we can see from this result that the patient with the last name Adams patient like I01 Dr. Jake and Dr. Neetu. Let's just show the tables again. See, let's take a new scenario. Let's say that the new doctor and call Dr. Harford has been just hired, and this doctor to the doctor's table. See, currently Dr. Harford has not seen any patients. If we look at the same query as before and if we run this query, then we will get the following result. This query is going to joins, which means that Dr. Halley will get discarded from the query result. As he has not been matched to any patients in the doctor patient table. See, if we want to include all doctors, including ones that don't have any patients, that you might thinking that we just need to change the first join to a left outer join, since the doctor's table is the left table. We should get all doctors written, right? Actually no, we don't. Instead we get the same result as before. So again Dr. Harford has been discarded from the query result. This has happened because join that followed the left outer join has efficiently negated that outer join. To understand this better, let's look this conceptual out of the output of the first join. See, the first join gives a conceptual result which includes the Hafford as we are doing a left outer join of a join, right? Notice, so that was produced a placeholder null as a placeholder for the patient ID, right? Null as the placeholder at the patient ID. See, result is then inner join to the patient's table on the patient ID. It is at this point that Harvard Harvard find any match, did not find any match. We have discarded from the final result because of course there is null is not joined the patient table. The final result is there the same as if we had used it in a join. On the way that we can address this problem is by making the second join as left outer joins, so that we have to left outer joins. We have to use two left outer joins. Now we have, see, we have to left outer joins. We have to use two left outer joins. See, now we have two left outer joins. Harvard is included in the query result. Predicate placement. Predicate placement on clause versus where clause. Let's see. Okay, we are going to predicate placement. So recall that predicate is SQL is a condition that evaluates true or false or no. Let's see, when we have a query that has a join in it, then we can place a predicate in even predicates. In even the on clause, we can place a predicate in the predicate in the where clause. If we are using a inner join, the predicate placement does not matter. It will return the same result regardless of whether we put the predicate in the wrong clause or in the where clause. However, if we are using an outer join such as left outer join, then we will potentially get a different result depending on where we place the predicate. Okay, let's go for some examples. Here we have two tables on the left. We have a table of suppliers, and on the right we have a table of products. The products table is the various products supplied by the suppliers. And if we look at the suppliers table, notice that we have a attribute called country for where the supplier is located. We have a few suppliers from India, and we have a supplier from Germany which is called it solutions, IT solutions. And also notice that the supplier called S Corp doesn't have any products that the products in the products table. So S Corp has a supply ID of 2, and if we look across products, we can see that in the supply column we do not have the value to S Corp has no products, right? So let's say we wanted to write a query to do the following. So we want to return suppliers from India, and the products they supply only return Indian suppliers that are supplying products. See, we don't want to include S Corp because the current don't have products. We can return this result by writing the following query. So in this query we are using inner join between suppliers and products. So it will exclude S product because doesn't have ID in products table, right? From India we want like select supplier dot from suppliers inner on supply ID is equal to where condition we have to use where India is the need. So this query will give us this result, 3 only. ABC Limited, XYZ Solutions supplies. also, right? However, this is also gets discarded from the query result as we are only keeping rows where country equals India. Right, so this query result, this is our first Indian supplier, and then we have one product for XYZ supplies. So another way of writing this query is to put the predicate in the on clause. Let's look at. So again we are joining the suppliers table to the products table using a join, and we are joining inner join, and these two tables on the supplier ID, but this time instead of using a where clause we are using and operator. See, this time predicate country equals India is placed in the on clause instead of where clause. On clause instead of where clause. On, yeah, right. See, and this produces the same result as when we put the predicate in the where clause. This is only true for inner joins, right? It is only true for inner joins. If we are using an outer join, then we would actually get a different result depending on where we place the predicate. Let's go for the predicate placement, but this time using a left outer join. See, predicate and so let's say we want to do the following return supplies from India and the products they supply, including supplies from India. They are not supplying any products, so this time we also want to include AC Corp even though they don't have any product ID in the products table. So we try writing the following query. Here we are using a left outer join, and supply is our left outer table, which means our query result will include all supplies even if they don't have any product ID. We have replaced the predicate country equals India in the workforce predicate. Here country is equal to India. See, select from left outer join on supplier ID is equal to supplier ID where country is equal to. Here it will give AS corporation also, right? Let's give us the following result. See, so as expected we get all Indian suppliers return including AS corporation, since a corporation does not have any matching rows in the products column, products table. It's get null in the query results. Just gets null in the query result for the products table column. That's it. Okay, let's try removing the where clause and instead paste the predicate in the on clause using the AND operator. So at first you may think that this will return the same result as before. However, this is not the same case. Instead the query will return the following result. So notice that we now get its solution in our query result, because it gives on supplier ID and why it will give sub idea from Germany. We are given India, right? Even though its solutions from Germany and its solutions, even though IT solution from Germany and IT solutions gets included because we are using a left outer join. Yeah, see, left outer join, it will gives all the records. So left outer supplies as all left hand table, and this means we are going to return all suppliers regardless of whether they meet the condition like in the AND clause. So in the AND clause now we now have two predicates and they both serve a matching purpose, right? The first one is supply ID equals supply ID, and the second product key is supply ID is country equals to supply. So AS corporation is included even though it doesn't have ID in product tables, and the IT solution is also included, and IT solution does not have a match nulls, IT solution does not have a match in the products table. So it's producing a product, it's producing a microphone, but doesn't meet the second condition, right? So and each row needs to meet both conditions in the on clause to be treated as a match. And of course the second condition, country equals India, so the Germany supplies ID solutions gets included in the query result because we are including, see, all suppliers, but it will have no rules for the columns coming from the products table. So in this case the predicate country equals India is not used as a filter. So this is something to keep in mind as it often trips people up. Okay, that's it for, so see you next time.